Mr. Moore's math class!
Good afternoon, guys, and welcome to Mr. Moore's online flip classroom. Now, guys, I'm extremely excited today because we're going to learn all about how to sketch the graphs of cubic functions. Now, I'm no longer talking about cubic functions that look like this. What I'm talking about is cubic functions that look like these. Yeah. Alright, so let's now have a look at a bit of an introduction on how to go about sketching these functions. Let's check it out.
Alright guys, so today we're going to have a look at how to sketch the graphs of cubic functions. Now in order to be able to do this, there's always going to be 4 simple steps. First step, step 1, is to go through and find the y-intercept, just like sketching any other graph. Make sure you make your x equal to 0, substitute in, and then simplify for y. Step 2 is to go through and find the x-intercepts, once again just like any graph. Now in order to be able to find the x-intercepts for cubic functions, what we need to do is identify how many different types of x we've got. So for example, if we've got just the one type of x, what we need to use is inverse operations, that is, use BODMAS and then work backwards in order to be able to solve for x. Now if we've got 2 or more different types of x, what we need to do is go through and factorize in order to be able to solve. Then for step 3, what we do is we plot the points and identify the different types of intercepts. So of course, like any time when we sketch a graph, go through, plot those points, and then we're going to come to the different types of intercepts that you can have in a second. And step 4 is to sketch the graph showing all points of interest. Now I recommend that you use the CAS calculator to assist you with this, because once you've sketched your graph, you can check it out on the CAS calculator, and if your graph doesn't look like what you've got on the CAS calculator, then you've probably gone wrong somewhere. Now when looking at the different types of cubic functions, there's actually a few different types that you can see here. That is, you can have something with a point of inflection like what you can see here. And of course, our point of inflection can be found at the point BC. Now in order to be able to find the x-intercepts, what we need to do is use inverse operations to solve. Now for this type of graph here, what you can see is we've got y is equal to x minus a in brackets multiplied by x squared plus bx plus c. And that's in its fully factorized form. Now the reason we've got that is because at this coordinate here is going to be a 0. Because our x coordinate will be a and our y coordinate will be 0. Now there's no intercepts here because this factor that you can see down here, the discriminant is less than 0. That means there's no solutions. So for a cubic graph that looks like this, where it comes up and goes through the x-axis only once, has a turning point above the x-axis, and then a turning point still above the x-axis, you've only got one solution, and that will be at the coordinate a, 0. So therefore your x-intercept is at a, 0. Now for this graph here, it's pretty special because as you can see, we've got an x-intercept here and an x-intercept here. Now what we can think of this as is sort of like a linear intercept, and this is kind of like a quadratic. Now the reason I say that is because this intercept here is at the point A, so therefore that is going to be at a, 0, and this one here is at the point B, it is b, 0. Now how do we know which one's which? Well, if we have a look at this here, that is our equation, we've got y is equal to x minus a, so that's going to be our linear one because it's a linear factor, whereas the next part of the graph, that is x minus b squared, well what you can see here, the squared part actually means that we have a turning point at that coordinate of b0. So therefore, a linear factor gives a linear intercept, that is what you can see here where it goes straight through, and a quadratic factor gives a turning point at the intercept like you can see there where it just comes down, touches on it, and then goes back up. Now the last type of graph that you can see here is one that comes up from the left to the right hand side because we're talking about a positive cubic, and then goes through the x-axis here, through the x-axis here, and then through the axis here once again. Now what you can see here is it goes through basically like a linear fashion for each case. The reason is because each one of these factors that you can see down here, that is x minus a, x minus b, and x minus c, are all linear factors. Therefore, it's got a linear intercept that it goes through. That is, it goes through pretty much almost in a straight line. Of course, because it is a cubic though, it has a slight curve to it, but the way I like to think of it is because it's got a linear factor, it's got a straight line going through the intercept, unlike the quadratic factor which had a turning point on the intercept. So therefore, 3 linear factors produce 3 separate intercepts, that is at the coordinates a0, b0, and c0.